Right. Hi, everyone. I believe so we are having a session right now with regards to Patrick Pathshala, which we do every Thursday at 9:30 p.m. So where we take a few concepts and solve. So it's still early. We will start in some time. Right. Um, so here we take up some concept which will help in different aptitude examinations. So any aptitude examination that you're looking for, I'm sure it will help out here. So we're looking for different type of questions, different type of areas every session, which could help you basically in preparation. So we'll start in some time. Yeah. So hi Muskan, hi Dipanshu, good to see you all. Hi Sachin. Yeah, Sachin, we are doing great. Yeah, good to see you all. Yeah, we'll start in some time. So just give me a couple of more minutes, 2 or 3 more minutes, and we'll start the session. Again, the idea is just to take a few concepts which we'll take up and then try to solve in the class. Uh, the concepts are basic concepts that should help you in any exam, be it government exams like banking exam, CET, CAT, GMAT. So the applicability of the concepts are there for different examination. The basic idea of a concept is to how to solve things fast. So if you're able to solve things fast, that will help you to solve more questions actually in the exam. So the whole focus has been how to solve things fast and just simple ways about how to go about solving them. Okay, so let's just try to go about it. What basically is aptitude examination? Aptitude examination is basically questions that they provided to you, which you need to solve things in a faster method. Normally, they have area broken down into maybe four broad areas as such. One is the verbal section, second is the logic section, third is the data interpretation section, and the fourth is the quant section, mathematics section. So when we are talking about this particular session, we focus right now on mathematics because mathematics is there across all aptitude examination. You talk about placements, you talk about placement tests, you talk about any government exam or anything. Mathematics is a common thread behind it because you require mathematics across any particular thing that you do. So that's where every exam has mathematics. The weightage could differ. Some exam may have lesser weightage for mathematics. Some exams may have more weightage for mathematics. But the weightage may differ. But what is seen across examination, whichever exam you write, normally the people who do well in mathematics are the people who are able to overall score well. I mean, there's a huge difference between people who tend to do well in mathematics and people who don't tend to do well in mathematics. So people who tend to do well in mathematics are then normally are people who tend to do overall well. I mean, if you look at the CAT 100 percentilers, they normally have a very high mathematic, like around 99.9 plus in mathematics. Same in almost all exam. I mean, because what happens in maths, you have a higher accuracy and higher marks, and the marks difference between a person who scores higher marks and lower marks is much higher. Okay, so that's where it goes about solving it. Right. So I will start in a minute. Right. Fine. So we'll start with the whole concept. So here today again we are doing the whole ratio method. We'll be again doing the ratio method. We did the ratio method in the first class, but the ratio method in the first class was time, speed, distance application. the application of ratio was in time to distance. Today, the ratio application is in terms of work sums. So we look at ratio and we'll look at how it is applied to sums on work. Okay, time and work. That's what today's session is all about. Now, let's just understand how ratio is used. Ratio is used in many different type of sums. The advantage of ratio is that in some of the sums it can be really fast in a traditional method, and that can save you a lot of time. Ratio is normally used when the product of two things is constant. For example, if I look at A into B is a constant term. I mean, this is a constant. So A and B are inversely proportional. So when A will increase, B will decrease because the product is constant. Right? When A will increase, B will decrease. So because the product is constant. So normally in time space distance, distance is equal to speed into time. I'm just giving an example where distance is constant. So speed and time are inversely proportional. So more the speed, less the time, or vice versa. So that's how it is used in time space distance, where they're inversely proportional to each other, and that's what helps you to understand and solve. So if you learn this particular method of ratios, you tend to be faster, and that helps you to solve more questions. Now today we are looking at application of this same ratio in work sums. We'll take a few sums which are based on work, a couple of sums that are coming in the CAT exam, and see how do we apply these concepts in those sums. Now, how do you apply the whole work? So the ratio of men into days, or number of work done, okay, work done into per day into the number of days is equal to total work done. Okay, that is one concept which is there. Amount of work done per day into the number of days is equal to work done, total work done. Now this total work done is normally constant. So in the work done sum, the work done is normally constant across, which means work done per day and days is inversely proportional. Work done per day is also called efficiency. Okay, work done per day and days are inversely proportional because work done is normally constant. So when you say A and B, so the amount of work done per day, okay, amount of work done per day is, say, A is to B. So number of days taken becomes B is to A, inversely proportional. The simple way to understand is, moment I do more work, the number of days taken is less. Okay, moment I do more work per day, the number of days taken is less. So moment work done is A is to B, the number of days taken is B is to A. So today when we solve a sum, we'll look at applicability of this particular concept which is there. We will also look at how to apply it in maybe a couple of CAT sums. We'll also look at how to apply it maybe when there are three variables available. How to reverse the ratio. Okay, there are two things that we are looking at solve. So we look at these two or three different ways and then try to go about trying to understand how to solve. So let's try to work on. Let's take the basic first type of question which is there. Read through the question. The question is, A can complete a piece of work in 24 days and B is 50% more efficient than A. Now we're talking of two things, A and B. Okay, I'm not doing a traditional work type of sum. I'm just doing by ratio method. If you understand the ratio method, it could help you better. So B is 50% more efficient than A. So if I say efficiency, as I said, efficiency is also work done per day. If efficiency of A is 100, then B will be 150 because B is 50% more efficient than A. So we say the ratio is 2:3 of efficiency. The ratio of efficiency is 2:3. That's where it comes. So if ratio of efficiency is 2:3, as I said, efficiency and days are inversely proportional. So the ratio of days will become 3:2. If ratio of efficiency is 2:3, the ratio of days taken is 3:2. Reverse. Now I already know A, 3 stands for 24 days. 3 into 8 stands for 24. I want how much B will take to complete our work. B, 2 into 8 will be 16 days. We'll straight away get the answer 16. Technically, you can do it only. So B is 50% more efficient than A. You can make out efficiencies 100 is to 150 or 2 is to 3. So days is 3 is to 2. 3 stands for 24, 8 times. So 2 will stand for 16, 8 times. You get the answer. So the advantage of doing these type of sums this way is that you can do it mentally. The moment you can do it mentally, you can do it much faster. Okay, these are all shortcut tricks that are normally used while solving the sum. If you really want to like score very high in sums, it may sound silly, but a lot of techniques or tricks that are there normally, which are very efficient, are normally simple techniques which you can use. Only thing, because we have normally used a traditional approach throughout our studying, so we find it difficult to adapt. But moment you practice a bit, I'm sure you'll be able to get it. Okay, now we're looking at similar sum, a little different way. So we are looking at ratios, as I said. So here again, A takes 4 times as long as B and C together. So they're given ratio of days. Okay, so A takes, I'm just doing it by ratio method just to understand ratio. You can do this by normal other traditional method by taking x and 4x, etc. I'm just explaining the ratio method because I just to show how it works. So we have two things out here, A and B and C together, right? So time taken, because they said 4 times as long, A takes 4 times as long as B and C together to complete the work. So we say A is 4, B plus C is 1. 4 times this time. Time is also days, you can say. Right? So we can say work done is 1:4. Reverse. The amount of work done is 1:4, which is total is 5. Total of A plus B plus C put together. You can add for work done by A, B and C. 5. So if I look at A and B and C, the amount of work done is 1:5. So amount of days taken is 5:1. I'm now looking only at A and B and B all three. A and all the three. Amount of work done is 1 and 5. So amount of days taken is reverse 5:1. If this 1 stands for 10 days, that means they together take 10 days to complete a work. 5 will stand for 50 days. You'll get the answer is 50. C option. Right? Again, the ratio you can do by traditional method also, but just be comfortable with ratio because some of the sums can really be fast with ratios. So here they're given time. Time taken is 4:1. So if you look at time taken by A and B plus C is 4:1 because A takes 4 times as long as B and C. So work done becomes reverse 1 and 4. So A takes 1, B and C 2 together take 4 work. So total work by them is 5. A, B, C put together, total work by them is 5. Now for us, the days of A plus B plus C is given. We are asked A. So we take these two, 1 and 5. Okay, take given A plus B plus C. We are asked A. So find the ratio. The ratio of work is 1:5. Ratio of days is 5:1. This 1 stands for 10 days. So 5 will stand for 50 days. That's why you get the answer as C option, 50. Another sum. Go to it, try to read it, try to understand it, try to solve it, and put the answer maybe in the chat box. A, B, C, work done. Now, B is twice as fast as C. If C does 1 work, B does 3 the work. Because they're given work, if I'm looking at work, B is thrice as fast as C. So if C does 1 work, B will do 3 amount of work. A is twice as fast as B. So 6. If B does 3 work, A works 6 work. Right? We want all of them together. So if I take A plus B plus C, all of them together will do 10 amount of work. Now they have given for A and we have to find all the three. They're given A and we have to find all the three. So we take these two, 6 and 10. So work done is in the ratio of 6:10 or 3:5 work done. So days taken will be 5:3. If work done is 3:5, days taken is 5:3. 5 stands for 5 days. So 3 will stand for 3 days. You will get the answer A option. Right? Again, you have A, B, C, and together A plus B plus C. If you have this, so you can make out that if C does one work, B will do thrice as amount of work, 3 work. A does twice of B, which is 6 work. Together they do 10 amount of work. So if you look at the amount of work done is by A and A plus B plus C. Why do I take these two? Because they're given A and I have to find out all the 3. So work done is 6 is to 10. So days taken will be 3. So work done is 3 is to 5. Days taken is 5 is to 3. So A alone takes 5 days. This 5 stands for 5 days. So automatically 3 will stand for 3 days. You get the answer as A option. Now, this will come in handy only if you start applying for a number of questions, and that's where this will help. Now, when you're paid is same as efficiency. How much you're paid? You're paid based on the work done. More the work done, more you're paid. So here, payment is basically based on efficiency. More the efficiency, more the payment. So that means using the payment method, I can find out how much work is done. A and B. If I look at, they're paid 24 is to 16, which is nothing but work done. You can say is 24 is to 16. Work done by them is 24 is to 16, which is 3 is to 2 by A and B. Right? So number of days taken becomes reverse, becomes 2 is to 3. You can do that. But because you want how many days must they take to complete the work together, if you want, you can take A plus B 5 amount of work. Now A is given, you A plus B as what we'll find out. So you can take out days taken by A and A plus B is 5 is to 3. Okay, days taken by A and A plus B is 5 is to 3. 5 stands for 4 days into 0.8. So 3 will stand for 2.4 days into 0.8. That will be the answer. Right? Clear? So again, work done is given, which is nothing but the amount paid is equal to work done. Because the more the work paid, that means more you do the work. If you look at A and B, it is 24 and 16, which is 3 is to 2. If it's 3 is to 2, total is 5. A plus B put together, because we want A plus B. So we are given A and we have to find out A plus B. So if I compare A and A plus B, the ratio of work done is 3 is to 5. The ratio of days taken is 5 is to 3. So we know 5 is nothing but 4 days. So 3 is how much? 0.8 times, so 0.8 times. You will get the answer as 2.4 days. That will be the answer for this. Right? Hope it's clear. This is a question CAT modified version, but yeah, similar type of question. Now here they given time. B needs 25% more time to finish the job than what A does. If I look at A and B, time taken means days, or you can say time, whichever. B needs 25% more time. So A does 100, B does 125, or we say 4 is to 5. Right? So work done by them will be 5 is to 4. Okay. Time taken is 4 is to 5. Right? Work done by them is 5 is to 4. We want A plus B is given to you. 9. Okay. The 2 finish the job in 10 days. So 2, we have both A plus B is given to you. And we have to find A. Okay, A plus B is given to you. We have to find A. So work done by A and A plus B put together is 5 is to 9. So days taken is 9 is to 5. Right? Work done is 5 is to 9. So days taken 9 is to 5. 5 stands for 10 days. Double. So 9 will stand for 18 days. Double. Second option. That's the answer. Ratio method. Right? So again, I take sum in CAT. You can use the ratio method and try to get the answer. A and B, the ratio is 4 is to 5. 100 is to 125 or 4 is to 5 is the time taken. So work done is reverse 5 is to 4. We can only add A plus B in work. Therefore, we can convert to work. So A does 5 work, B does 4 work per day. Together they do 9 work per day. Now we have to find out A and A plus B, because A plus B is given to you. We have to find A. Reverse it. Days taken is 9 is to 5. If work done is 5 is to 9, days taken is 9 is to 5. 5 stands for 10. Double. So 9 will stand for how much? We'll get 18 as the answer. Right? Yeah. Go to this, try to solve. Still on a different side. So here, if you look at it, they're given again the time to do twice as much time, 1/3 as much time. Okay, in the end, they're given 3 days more by John and all three of them. So let's, since there are two concepts, we take each of them separately. Let's say John and Jack. Okay, John and Jack. Okay, twice as much time. So days, if I look at it, John takes twice as much time as Jack to complete a work. So work done will be 1:2, John and Jack. Right? Same way, if I look at Jack and Jim together, Jack plus Jim and John. Jack and Jim take 1/3 of the time. So days taken is 1:3. 1/3 of the time what John takes. So work done is 3:1. So if John does one work, if I take it John, if I combine it, John does one work, Jack will do two work. Okay. And Jim will do one work, because Jack plus Jim does 3 work, so Jim will do one work. Right? Jim will do one. Now we want all three of them if you look at it. Jack plus Jim plus John. All three of them put together. The work done by them is 4. Okay, work done by them is 4. And work done by whatever they given. 3 of them working together. And John. So John will take 1. Right? So Jack plus Jim plus John is 4 and John is 1. That is the work done. So days taken will be 1:3. Now they said difference in the days. Okay. 3 more days. So 1 and 4, the difference is 3, which is 3 days. So John takes 4 days to complete the work alone. John takes 4 days to complete the work. If John takes 4 days to complete a work, if you look at John and Jim do same amount of work, so Jim will also take 4 days to complete the work. The answer is 4. I'll repeat this. It looks like complicated, but if you're used to the ratio method, it becomes much faster to solve. So let's look John and Jack. John takes twice as much time as Jack. So the work done is 1:2. Reverse. Jack and Jim, 1/3 of John. So work done is 3:1. If Jack plus Jim does 3 days to complete the work, right? Jack plus Jim take 3 days to complete that 3 work. Amount of work is 3, and Jack does 2 work. So Jim will do 1 work. We can do this because John work in both the cases same. So if you look at Jim will do same amount of work as John. Now again, coming back, work done by all of 3 and John is 4:1, because 2 plus 1 plus 1 is 4 and John alone takes 1 work. So days taken is inversely proportional, 1:4. Difference of 1 and 4 is 3. 3 stands for 3 days. So John alone 4 will stand for 4 days. But John and Jim does same amount of work. So answer will be, they will take same number of days, which is 4 days. Looks complicated, but if you're used to the method, you should be able to do it fast. Not forming any equation, not forming anything. I know it is three variable stuff. If you form a traditional method, it will take you a much longer time than ratio method. Okay, now we are using three variable and ratios. As I said earlier, we're looking at three variables and then doing the ratios. A, B, and C. Right? A, B, and C. Yeah, hi Suraj. If you look at it, work done is 5, 10, and 15. 20, sorry. Work done is 5, 10, 20. When you say days taken, sorry, days taken is 5, 10, 20. If I want to reverse and find the work done, find the LCM of 5, 10, 20. What's the LCM of 5, 10, 20? 20. LCM of 5, 10, and 20 is 20. And just do 20 divided by 5, 4. 20 divided by 10, 2. 20 divided by 21. That's how you reverse the ratio. So you take 5, 10, and 20. Or you can take 1, 2, and 4 also. That's also fine. Take LCM of the three values, which is 20. So if I want reverse the ratio, work done. So take LCM, this is LCM, 20 divided by 5 is 4, 20 divided by 10 is 2, and 20 divided by 20 is 1. So ratio of work done is 4 is to 2 is to 1. Total work done is 7. Now, amount paid is equal to work done. So 7 stands for 14,000 into 2,000, that is. Difference in A and C, which is 3. 3 will stand for 6,000 into 2,000. That's the answer, D option. Right? Now decide we can have three variable stuff and reverse the ratio and then try to find out. Days taken is 5, 10, and 20 again. So you have to reverse the ratio. Take the LCM as 20. So work done is 4, 2, and 1. There's 20 divided by 5, 4, 20 divided by 10, 2, 20 divided by 21. This is a reverse ratio. So total work done by them is 7. 7 stands for 14,000 because you're going to be paid based on the work done 2,000 times. So difference in A and C is 3. 3 will stand for 6,000. So these simple techniques and tricks that you can use to solve the sums. If you do this, I'm sure it will help you to solve things faster in the exam. But try to use it. I mean, you learning the techniques is one, but then applying them to different type of sums is what is important. And the key to going fast in any exam is to try to use these techniques as far as possible. If you can use it, you can be really fast as far as the exam is concerned. Right? I hope this is clear. Okay, if you have any specific topic you want me to cover or any specific type of sum, do let me know. I'll try to cover in the sessions on Thursdays that week too. So every Thursday at 9:30 we have a session. So you can ask me questions. I'll try to answer to the best of my ability, and hopefully it will benefit you as far as the exam is concerned. So more videos on that. You can always subscribe to the channel, and you should be able to access a lot of videos. There's also Road to 100 series which is there, which is also good sums, but little difficult sums, which help. There's a Road to JB for faster calculus, speed-based exam like CET, banking exam, etc. Road to 100 is mainly for CAT exams. So you can look at those concepts, and that also will help you to solve. DI, okay, I'll try to take up DI as far as possible. Right, I'll try to take up DI as well as possible. You can do by percentage method. Okay, yeah. Suraj, you asked me about percentage. If you complete a work in 5 days, one day you will complete 1 upon 5 or 20% work. If you complete a work in 10 days, you do 10% work. If you complete work in 20 days, you will do 5% work. So they do 20% work, 10% work, 5% work, or you can say 4 is to 2 is to 1. 7. 7 stands for 14,000. Same thing. 4 minus 1, 3 will stand for 6,000. Percentage method. It will be the same way. You are just using a percentage to find a ratio and then try to get the answer. Elevators and train, I'll take it. I'll take DI, yes, I'll try to take that. I'll try to. Elevators, yes, it's not difficult to solve. We'll try to look at those also. Maybe as and when we go, we'll try to take up those concepts in the class. Hopefully it should help. Right? Okay, so wind up here today. Thanks for being there. Good night. See you in the next session.